Here we are, the final session of the industry track. Welcome back to this track, and the future is counting on us. Sustainability hidden in plain sight. With us today to wrap up this track is Peter Dorlin, Emeritus University Architect and Associate Vice President for Planning, Design, and Construction. Peter brings decades of experience in design and construction and is going to walk through the hidden opportunities that make projects more sustainable from the ground up. Let's give Peter a big hand as we close out this track.
Good afternoon. I'm Peter Dorline, and I'm currently a consultant to the AEC industry regarding understanding the owner's perspective. And the reason I can consult on owner's perspective is because I've been with the University of Arizona for 32 years as the university architect and AVP for planning, design, and construction. Before all that, I owned a small design firm where I learned all the things they don't teach you in school about business, and I was also a construction superintendent. I'm now emeritus from the University of Arizona, which is a fancy way of saying I'm retired from there. So we all know that the developments and buildings we design and construct today and how sustainable they are will impact us for many years to come. So we owe it to ourselves and to our future to make the most informed and durable decisions now. The future is counting on us, all of us, right? So it's really important that we do that up front. So what is sustainability hidden in plain sight? Well, certainly carbon footprint is important to measuring sustainability. Things like energy use, air conditioning, lighting, building envelope are all relevant. And we know that third-party verification systems are out there for the design and construction industry and to measure sustainability. Things like the U.S. Green Building Council rating systems, smart and green building systems, and tools like Energy Star. These are fairly known in our industry and represent many visible green building factors. Most of us are all over these. So what sustainability factors are hidden in plain sight? We'll go through some of the biggest building sustainability impacts that are not always considered or readily seen. Here are a few standardized definitions, and as a scaffold, I'll quickly recap a few terms so that we're coming from the same foundational context. We know that the built environment represents a significant carbon footprint, which is the carbon associated with the operation and maintenance of a building over its life cycle. This is largely the future impact. Some say about 40% of carbon emissions come from building energy use alone. And there is also the embodied carbon. Embodied carbon accounts for all the materials and ingredients in your building, and the carbon associated with all the activities related to their mining, their extraction, processing, and transporting. Together, all these represent the total carbon footprint or impact. Generally, we think of carbon emissions as those created from burning fossil fuel, say to make electricity or to transport things. And certainly, we do lots of that in constructing and occupying buildings. So putting it mildly, there is a lot of carbon associated with building a building, and it all matters. So what can we do to reduce the carbon impact that we may not already be considering? As I mentioned earlier, the U.S. Green Building Council LEED rating system is one of the most widely used green building rating systems in the world. It's a framework for independent third-party verification and is geared toward creating healthy and efficient buildings and providing environmental and social benefits. These are the 7 primary goals, which are fairly universal when talking about the impacts and opportunities of the built environment. Many of you are very familiar with these. And for those of you who aren't, there's lots of additional information on the USGBC website. So if these are the more typical factors involved in making our buildings more sustainable, what are the more hidden or invisible factors that we can consider that also have a significant effect on the carbon emissions and footprint? Let's jump in. Sustainability, hidden in plain sight. So these are the topics that we'll be going over in the next 7 slides. These 7 topics are my list of the what I believe to be largely unseen issues and decisions that can have a significant impact. To build or not to build. This is an important consideration even before designing a building, that it's not, and that's not a visible part of our new development. So we already discussed there's a whole lot of carbon footprint and embedded carbon in constructing and occupying a building. So the first question we should ask is, can we not build? Can we accommodate the need in some other way? Can we repurpose something existing? If not, can we renovate instead of building? If not, can we add to something existing or any combination of these? Can we avoid designing and constructing and operating a totally new space or building? That would be the most sustainable thing to do. These considerations are not readily seen, but important. So if it holds true that the most sustainable thing we can do is not construct a new building, then it also holds true that the smaller we build, the smaller the potential carbon footprint, the greener and more sustainable our project can be. But how can we do that? How can we build smaller? First, we consider if the parts of the program, if there are any parts of the program that can be housed perhaps in another existing facility to reduce the scope of our new endeavor. After we've considered that, one way to build smaller indoor footprint, depending on the region you live in and the climate, is to consider using more outdoor space for programmatic needs. But how can we use outdoor space to accommodate program? What if we can temper the outdoor space? Can that expand its programmatic usability and perhaps reduce the indoor footprint and the carbon associated with that footprint? Oftentimes we can. In Tucson, Arizona, at the University of Arizona, we have a building constructed now 10 years ago, but it still demonstrates some of the most sustainable design and construction practices. We call the building ENR2. Since ENR2 represents those values so well, I'm using it as sort of a case study today. The building is largely rectangular in its form. It's an office building with some classroom space and a dry or computational research spaces. The occupants are mostly earth and environmental studies folks. Campus is in an arid region that certainly sees some freezing temperatures, but it is largely an overheated environment in the summer months. While it's fairly simple, this sort of rectangular building on the outside, 6 stories. On the inside, it's an open air courtyard that emulates a slot canyon, undulating to the roof and to the sky. Slot canyons are found in this region. You see one here on the lower left of the slide. This natural influence is part of the building's biophilic design. More on that in a minute. The building is a third smaller than the size the program actually required, but still serves all the functions that were needed. How is that possible? That was enabled largely through the use of tempered, protected outdoor space for secondary functions. Let's explore that. The building has a couple significant auditoria. One has 600 seats, and yet there are no indoor lobbies. There are half dozen departments located here, but there are virtually no indoor hallways or stairways. And the outdoor courtyard and undulating outdoor balconies on each floor serve as the circulation space, the gathering space, the queuing, the event, and the study space. Going from one department to another is largely via the protected, tempered outdoor circulation spaces. Even the elevators and stairs and restrooms are accessed by going outside through the protected balcony and courtyard spaces. When it's great weather, that's easy. But what about when it's freezing outside? Or in Tucson, what about when it's 110 degrees? We greatly expanded the usability of these outdoor protected spaces by strategically tempering them. So here are the factors. The tempering comes primarily from 5 sources in this environment. And since the facility is largely, in a largely overheated environment, I'll focus mostly on how it tempers the heat. But there are similar strategies in some of these that can help with other climates. Shade. There are deep recesses from the overhanging balconies, and the slot canyon design is a fairly narrow shaded vertical space that opens to the sky. The patinaed metal angles, or fins, you see some of here, provide lots of shade in the right places. Thermal mass. The building is largely a concrete structure, and the concrete mass acts like a heat sink, in our case, absorbing heat in the day and releasing it at night. Air movement. Air movement has a cooling effect, and there are large thermostatically controlled fans on the outdoor balconies. And the courtyard design provides a natural convective current to remove heat and help provide cooling. Relief air. This can be done anywhere. Buildings generally recirculate heated or cooled air for efficiency, right? As return airs, they recirculate the air. But there is also a large amount of fresh air brought into the system to remove the carbon that builds up from, say, our breathing, especially for spaces like an auditorium where there's 600 people breathing. As that fresh air is injected into the system, already conditioned room temperature air must get pushed out. This air is often typically released out through the roof. But since this air is already tempered, we chose to release it strategically into various locations and levels of the courtyard and balcony spaces. Trickles in. These actually temper the courtyard. Lastly, but very importantly, there are plants in the courtyard and on the balconies at every level and even on the roof. These plants and their rain capture irrigation provide transpiration and cooling. In essence, the building provides an environment for the landscape, and the plants provide habitat for the people while helping to cool the building. In my opinion, every building should be integrated into the landscape. It should be a collaboration of building and landscape, not two separate thoughts. These kinds of tempering are fairly hidden to the casual observer as sustainability features, but highly effective in allowing the conditioned space of the building, in this case, to be a third smaller. Occupant behavior. Winston Churchill said, "We shape our buildings, and thereafter they shape us." What does that mean? How can a building shape us? I'd like you to think about what that means to you. When we design and construct a building, yes, we are shaping the building for how it will be for a very long time. After it's shaped, we naturally must conform our use of the building to what exists. So it's obviously really important to consider the long-term effects of the layout and design on our behavior and our experience. Consider the last time you stayed at a hotel. Maybe you had a room, say, on the second or third floor. Did you walk up the stair to get to your room? Probably not. Maybe not. Most hotels are designed with elevators front and center, and the stairs are just for emergency egress to go down and out in case of fire. You might be challenged to even find the stair up from the lobby. And the entry from the lobby level might even be locked outside. So we generally are encouraged to use the elevator. In ENR 2, on the other hand, the stairs were placed prominently at either end of the central courtyard. You see one on the right. And an artful stair that dances its way to the upper floors was placed right in the middle of the courtyard near the main entrance. Meanwhile, the elevators were placed off in the corner. So if you enter the courtyard and you're able-bodied, and maybe just going up a floor or two, people are encouraged to take the stairs. They're right there. What's good about that? Well, it's probably good for the individual getting the steps and exercise. It's also good for the energy profile of the building in that you're not causing the use of electricity to push the elevator up and down. This is a simple example of the layout of, and the design of the building shaping our behavior, not just on day one, but for the entire duration of the building, maybe 50 to 100 years in the university's case. Again, this relatively sort of invisible regarding sustainability features, but very impactful. Fundamentals and technologies. So we're pairing those up. Every region and climate has its own unique challenges and opportunities. Many areas use lots of energy and resources to keep the indoor spaces warm certain times of the year. As I mentioned, here in the desert Southwest, we're in a largely overheated environment, and we work harder in the summer to keep indoor spaces cool. So employing solid design fundamentals in the desert Southwest means things like not placing a lot of unprotected fenestration or windows on the south or the west sides of the buildings. Or we consider shading the sun side walls and windows with porches, overhangs, or wall envelope treatments. At the same time, it's important to pair solid fundamentals with employing the best technologies available, say for things like high-tech insulated window systems and building envelope systems to minimize heat transfer. Using high-tech systems controls for things like lighting and HVAC have a significant impact on energy use. So the combined effect of solid fundamentals and great technologies are multipliers of each other. They can multiply the good or the bad. So leveraging from the beginning can be the best long-term investment, create long-term benefits in cost, in efficiency, and sustainability. Again, these may not be readily recognized by the casual observer as sustainability features, but are very impactful. Oftentimes, complicated materials and assemblies represent a larger carbon footprint. Locally sourced materials that are recycled, or at least recyclable, tend to have a lower carbon input and can really help minimize the carbon impact of a building enormously. For instance, in this case, you see a lot of steel. Steel can be derived from recycled material and can be recycled at the end of life of the building as well, affecting both the now and the future. And in this case, the steel patina, which is sympathetic to the red brick and terracotta colors of our historic buildings on campus, also never requires painting. And as it ages and leaves a bit of rust staining in its drip lines, it is even more like a slot canyon in that it erodes and changes over time. Biophilic. In this case, the use of simple steel angles as guardrails, as handrail supports, as sunscreens, and sculptural elements is economical, sustainable, and beautiful. That's a win-win-win. We discussed earlier that there are plants and rain capture irrigation in the courtyard and at every level of the building. This creates transpiration and shade. It has a huge effect on the building's energy use, not to mention that they create beautiful views, produce oxygen, and sequester carbon. And plants certainly contribute to the biophilic design. This biophilic design emulates the natural slot canyon in both its form and function, provides access to natural sunlight, and provides views to the outside and to plants. Together, these create an environment that actually inspires productivity and health. So human productivity and health aren't always readily visible or recognized as elements of sustainability, but they certainly are. Imagine the impact over the life cycle of a building if the people there are healthier and more productive. We often overlook the power of nature in the built environment. These are relatively invisible as sustainability features, but very impactful. Our last set of hidden in plain sight sustainability considerations are issues that affect the ability for occupants to control their own environment. It's been well proven that occupants or employees have some level of control of their environment, that they can be significantly more productive and potentially healthier as well. A little but effective twist in the lighting controls at ENR2 is that the lighting in most offices, the ones along the outside glazing, is controlled by vacancy sensors. And most of us know about occupancy sensors that turn lights on when the controls sense occupancy. But here, given the nature of natural light usually available, the lights must be turned on manually. But if you leave and the controls sense vacancy, they will automatically shut off. It'll also reduce the air conditioning volume when it's vacant. And the lighting in the shared open office spaces of the building have been designed to really be sort of the minimum required for safety and egress, rather than lighting up the entire space like Walmart all the time. Instead, each workspace has a desktop dimmable desk light, a task light that's dimmable at each workstation. So it's a small thing, but this significantly reduces the total electrical, the lighting load associated with the building. and gives the occupant direct control over the amount of light that they have, rather than sitting right under, say a fluorescent fixture. Someone can control that desktop dimmable lighting. Similarly, through the use of low volume underfloor displacement air conditioning and chilled beams located in strategic locations, the HVAC requires significantly less energy, and the occupants have additional control of temperature within a selected range. Again, giving occupants a level of control over their own environment while also providing views to nature, natural light, good air quality, can help their health and productivity. These are relatively invisible sustainability features that can be hugely impactful. Okay, wrapping up. While these features, characteristics, and assets are largely hidden or invisible to many, they can have a significant impact on the building's carbon footprint and human productivity over many, many years. And since the future is counting on us, all of us, it is my sincere hope that these are now less hidden and more in plain sight for you, and that you can shake up the traditional concepts to influence future projects in new and beneficial ways. Thank you for your participation today and for your concern for the environment. Feel free to submit questions and I'll do my best to address them. Okay, I guess we have a little time here for Q&A, and I see a few questions in the chat. The first question is, how can owners and design teams more effectively evaluate whether a new building is truly necessary before moving forward with construction? It's an excellent question. I think that it starts with the interview process when you're selecting design and construction teams to make sure that they're sustainably focused, and not just sustainably focused for design and construction, but for the lasting effects of the building, how it's operated and maintained, and how users will interact with the building. So I think that's really, important right from the beginning, and even in the team that you're selecting. Another question is, what processes or frameworks can organizations adopt to ensure these subtle but high impact strategies are considered early and consistently? Again, from the beginning, it's important to have a great team that you're working with, but also to, in an exhaustive way, really work with the user groups and the requesters of the building to make sure that every aspect of how they're going to engage with the building, why they need the building, is there any other place, that they could do some of these functions like that, that's going to have a long, sort of a long life in the building. So important to, to really consider that from the beginning. There's a question about AI data centers, and yeah, that's a big thing right now. They require such big resources of water and cooling and energy. How do we implement sustainability related to data centers? That's a tough one, because they do use a lot of resources. I hear that folks are considering, different reuse of water, not just one time through kind of water use, but storage of water and cooling of the water, so that then it can cool a data center. But there are strategies depending on your region, with things like geothermal, and of course, if the energy that's being used is largely renewable energy, that helps. If it's wind or solar or some other renewable energy, maybe battery, that helps to offset the footprint of the building and its operation. Yeah, there's a question about whether, I'm from the University of Arizona, whether we've used geothermal. We have not. It's not as applicable in our region, but it certainly should be something that's always checked, depending on your region. And there's a question here about how do you see the energy efficiency culture moving if subsidies for sustainability continue to be removed or reversed? I think that's a really good question. I think that anymore sustainability has more return than just subsidies. So I'm hoping that, like for a university, it actually helps recruit. The more sustainable we are, the more students want to come to an institution like that. But also that there's energy savings, that there are other returns. And I think that's really important for your team to evaluate. What are the returns? They were winding down here. There's another question about, was the building shown LEED Gold or Platinum? Net zero. So this was 10 years ago that it was built. It is LEED Platinum. It was the university's first LEED Platinum building. And because they were a little late to the LEED sustainability kind of getting that kind of rating, but it is not net zero. I think in today's overall, the building is net zero because the campus has a lot of renewable energy. However, it wasn't a target at that point, so no, it is not. But you can tell that there's a lot of values that show up in that, a lot of the university's sustainability values that show up in that building. I think I'm at the end of the questions I see posed here, and I really want to thank you for participating. Hope you get inspired to consider some things that maybe you hadn't before.